Hello and welcome to my talk, Domain-Driven Design, Why Should You Care? My name is Adam Dimitryk. I'm the author of the book, Hands-on Domain-Driven Design with .NET Core. So what is domain-driven design? I heard many definitions what it is, and apparently people tend to spend quite a lot of time explaining what it is. But I like this particular definition by Von Vernon, who says that domain-driven design is nothing more than developing a object language within a bounded context. It might sound a bit cryptic from the start because what is ubiquitous language? What is bounded context? These are terms from domain-driven design that maybe scare some people away. But let's go through this and find out what those things actually mean. For me, domain-driven design stands on, it's separated into two parts. One part is the strategic design, and the second part is the tactical design. I see that a lot of developers concentrate their effort on learning tactical patterns of DDD, which is, in my view, is much less important and useful compared to strategic design. So I mostly concentrate during this talk about strategic domain-driven design. And I won't touch patterns like aggregate repository and stuff like that. So, I mean, these patterns are described. Maybe they deserve attention, but this is a different topic. Let's look at three pillars of domain-driven design that I find particularly important. First is domain model. The next one is ubiquitous language. And the third one is bounded context. So you've seen ubiquitous language and bounded context mentioned in the definition. And we added the main model on top of that because basically the foundation of our software is what happens in a model that we design to solve particular problems of our domain, where the domain is the area of business, the line of business where your application, your software operates and solves real life problems of real people, so to say. So let's talk about a model for a while and what domain model means in DDD, and actually not in DDDs overall, the same approach. So let's have a look at this picture. This is the London Underground map, and it serves a particular purpose for commuters and tourists and others to navigate through the relatively complex system of multiple train lines in London Underground, overground river services, and light railway. So if you look at this blue thick line at the bottom of the map, you can see that it represents River Thames, but it has nothing to do with the geographical representation of the river or geographical sort of placement of the river. This map is designed to solve a particular problem. That's why it looks a bit awkward if you try to map it to the actual topology of where these lines are located, to the topology of London City. But it's very useful to find your way between two particular stations and how many changes you need to make, and what is the shortest route between those two stations. For any other purpose, that map is probably not that useful. Therefore, it's a model of the London transportation system that is created with that idea in mind, to solve a particular navigation problem, where for any other business it might be not useful. It doesn't even tell me how much time I spent changing trains between different lines. It's just one single dot that I might need to switch from central line to another line, and it might take me even more time than actually taking the train, because the passage between those two stations is particularly long. This is the disadvantage of the map, but I find it less realistic that someone could figure it out to actually find a way to represent the transfer times as well. So although the model is not actually ideal, it's the best they come up with. This is another representation of the same system using a bit different notation. So it concentrates maybe on the circle zones representation, because then you would know in which zone you travel, how much you're gonna pay. But at the same time, it occupies quite a lot of space. Maybe that's the reason why it didn't really pick up traction. And if you can see, I tried to squeeze it to the screen, but it doesn't really fit there. So I had to cut the top corner of the map, the top part of it. But it serves the same purpose. It tries to make it nicer. So you can find different models to solve the same problem within the same domain. And you need to evaluate the validity of those models and usefulness of those models in order to find out the best one. This is actually how the reality looks like. And if you look at this central spot, I need to move a little bit. So if you look at a central spot of London and find the conglomerate of stations over there, you can really think of like how can I possibly navigate using this map. So it is very useful. It is a very useful map. It's interesting to see where stations are located, compare it to geographical topology and the actual placement of the river. But it's not very useful for navigation unless you are an enthusiast of geography and you really want to see things, how close it is to the forest and stuff like that. So that's why this Never map has never been actually used for navigation purposes. And why I found it, I found an article saying Transport for London made a secret map where it actually shows geographical locations of train lines and stations. So it has never been really exposed, but I guess if it would be, it won't be that useful anyway, so people would never really use it, because I can hardly see how it can be valuable for commuters. So the domain model is not the real life representation of real life. The domain model is a set of abstraction describing a selected part of the business of the domain to help solving a particular problem within that domain. So you might even find that the domain itself can have different models represent different problems. So we say that the domain itself is in the problem space. So I mean, no matter what we do as software engineers, the problem space remains the same. So let's say for transportation in London, the problem space that we looked at was navigation. The solution space, however, is under our control. It's us as engineers and architects who decide how we're gonna solve that particular problem and which model we choose and which model we can apply for the solution. So it's a translation between problem space and the solution space. That's what domain modeling is about. So I wanted to demonstrate the concept of the same domain, or well, if we look at a global scale, yes, that's the same domain. There are different subdomains though, but anyway, these are different models. And let's say we are within a domain that represents the concept of a station of London Underground. And you can see a model on the top right, which is the station layout of Piccadilly Circus. This model would never find itself on a navigation map that fits to your pockets to show the whole layout of London Underground. However, for particular navigation within the station, it might be useful. If someone decides to put it on a wall, people will appreciate it. So the station layout shows you actually how much transfer time you would need to go from one platform to another and underground line to another. So that is one model for the station. Another model is on the FLIR folder below, which shows the heat map of the train coming to the station and rails, tracks. And that's a completely different model. It serves a different purpose. It serves the heat analysis and trying to find the ways how to cool the stations and maybe optimize the heat exchange. But that has not very little to do with station layout per se, but it might influence the station layout, but it deals with a different problem in hand. The big picture shows the construction site for Crossrails, which is now called Elizabeth Line, which is a tremendous project executed by Transport for London. And I mean, the amount of details, the number of things that happen during the construction, it's astonishing. And of course, within that domain, you might find models of heat maps. You can find models of station layout, of course, the build stations. But overall, there are so many details that go beyond the layout, that go beyond the heat maps. They have tons of other things to consider. But nobody is actually having the ownership. Like, they do have an overview of what's going on. But the subcontractor that's sitting in that crane doesn't really care about the heat map. They care about the model that they have in hand to build a solution that they're supposed to build within their own solution space, right? So the problem space is the same, but the solution space for the crane operator is different. They really need to move things around. And the solution space for these huge boring machines that are going through the ground and tunnels, building tunnels, that's a different story. So they have their own subdomain that they deal with, the geology, all the infrastructure that has been built in central London for many hundreds of years since Romans, and try to kind of move through the city without demolishing half of it. So that's a challenging task on its own, but again, that's just a part of the domain. Imagine that you try to understand and try to encapsulate in a software all these things together and build a comprehensive model to kind of cover it all. It's nearly impossible. It's just the scale of the thing is astonishing. So that's the mistake that many people make, trying to model the whole business at once in a single model, in a single piece of software. It often finds itself in the relational database with hundreds of thousands of tables and stored procedures and such, and millions of lines of code that quickly becomes unbearable. So that's why we talk about domain models within a context. So the model always makes sense only within a certain context. So if you expand the context, there are just too many things coming into the model that you might not even need to solve the problem in hand. So that's where we come to the concept of bounded context, that we draw the boundary around our context and try to encapsulate a model within it. And that's a very useful pattern, because you try to find your solution space for the problem in hand and not try to model the whole domain. So we have three contexts here. So there is one context of probably ventilation and heat distribution, another context of building the station and moving people around the station in the most effective way, and the third context is multiplicity of contexts. Basically, you couldn't even find a single context in there on the construction side. There are many things going around, happening, and it's very unnatural that it's kind of like, let's say they have a monolithic system and people working on the same thing all together. I mean, how the construction industry would ever work? They don't do things like that. I'm surprised why we as in software industry do it all the time. I mean, people often say, I know everything about my piece of software because I built it with a group of 3 people when we were a startup, and now we are like 300 people and nobody knows what's going on except of me. So something wrong with all those guys or girls. It's not. I mean, you knew that, you kind of grew up with that system and it's your baby, but you might even not know nitty-gritty details anymore. But again, there is no one really knowing all the details going on the construction side of such a complex project like Crossrails. Everyone is responsible for their part of work. Everyone is working with their own context. And that's how they parallelize the work. That's how actually the project moves. If that would be something like we usually build software as a monolithic system, they get stuck after a few months. Imagine thousands of people, hundreds of machines, a lot of materials, a lot of planning, and they would be doing some Scrum meetings and plannings and groomings and not actually being able to do anything because everyone steps on each other's toes. So that's just not going to work. Why the context? I mean, context and ubiquitous language, I mentioned it before, they're kind of, you feel like they are interconnected. The context is always something that comes to us from linguistics, and domain-driven design is not an exception. So the language is contextual. So on the previous slide, I show you the station. All of this is a station, but every context deals with that term differently according to their solution space, according to the problem hand, which is a very fine-grained, in at least two of them, but not in the third one, very fine-grained solution space for the term station. But imagine that you design the software again and you build a table that's called station, and you start shoveling around things like temperature of the tracks, number of train passing by, its geographical location, the layout, number of escalators, the width of the tunnels, and particular model of the train that can fit into the tunnel, and the passenger's throughput, a name and decoration, and a lot of stuff. And then you're stuck because basically nobody can take care of one gigantic entity that consolidates such a big number of unrelated details, really. So it's very useful to split things into context and make things contextual. That's why the context, we call it bounded context, because we're trying to isolate it from anything else. And that's where the language lives. So this is another example of context. The computer context is seeing the train as a kind of transportation medium. So you go into the train, move from one place to another. You care, of course, that the train comes, it doesn't break down. It's reasonably comfortable, preferably it has air conditioning, and it goes to the right place. But that's all you really care about when you look at the train. You don't even know the name of the driver and stuff like that. You don't know how many kilometers or miles are on the odometer of this train, how much power it consumes and stuff like that. That's not your concern. It's a completely different context. But there are people that take this seriously. This is their business. So they actually build those trains, and they have lots of different concerns about the train itself, the construction, reliability, all this wiring, the windows, again, air conditioning and stuff, and driver seats. So maybe even autonomous trains. And again, even if you build in the train manufacturing industry, they have a bunch of contexts on their own. So apparently people that are building air conditioning might not be that much involved in building the wheels, because this is a different story. It's more mechanical. That is more sort of pressurized gas, and there is a bunch of electrical concerns as well. People that are building autonomous trains maybe have a completely different set of concerns, and they would never influence how other professionals build wheels for that train. That's also allowing them to parallelize the work. So it would be the same people using the same tools to build the wheels and air conditioning and autonomous driving and opening doors and seats and stuff like that. They would never be able to build a train in time. So here we come to the sort of end of the description of those pillars of domain design that I wanted to talk about within the context of strategic design. So there's quite a lot of into tactical design that you can look up. There are some patterns that I find very useful, like the aggregate pattern and the value object and entity as such. Some patterns that I rarely use, like repository pattern. So this is the toolbox basically, but you might not use a single pattern of tactical design and still concentrate on the finding ubiquitous language, finding your context boundaries, and build a proper model within it. that you will already be doing domain design. I don't believe in books that saying, okay, we do aggregates and repositories, so off you go, you're doing DDD. That's what's called DDD Lite. It doesn't exist. It's not DDD. It's just a bunch of pretty useful patterns, but you can also apply them wrong because, for example, the aggregate pattern needs its own boundary. It only makes sense within a certain domain model that lives within a bounded context and uses ubiquitous language. So I think I haven't mentioned why language is ubiquitous. That's why it's kind of going to from top to bottom and bottom top. Everywhere in the problem space and the solution space, we use the same language within that particular context. So at least we don't have that much of a context switching when we talk about station or the train, depending where we are. Either we are on the commuter side or we are on the train manufacturer side. We know what kind of train we're talking about. So that's important because, again, context switching is a hard thing. Our brain is not very, it loses plasticity for in around 25 years and regains plasticity after 50. So I'm soon coming to that point that I will be having plastic brain again. But between those two kind of milestones, our brain is kind of quite rigid. So that's why we have a hard time learning new things and really need to push ourselves to become rigorous learners. So using ubiquitous language that connects problem space and the solution space within the contextual boundaries help you really to release some of the burden and work with things that kind of fit in your head, right? This principle, this fits in my head. I can understand it. I can reason about it. As soon as things get out of context and you never know what people are really talking about, you need to ask them, or you're afraid to ask because you think you will look stupid, but then you out of context and you don't know what happens. And you might even agree with everyone, and then you go out of the room and start building something and then find out that it's completely wrong. So context switching, avoiding context switching is important. That's why we try to bind it, or sort of make a boundary around it and use the same language within the context. And it's ubiquitous because you use this language to talk to subject matter experts, who we call domain experts. You use it in the code, you use it in a test, you use it when you talk to UX, you use it when you talk to QA. And by people actually can read your code if they have decent coding skills, or at least some coding skills. You can show them your tests and maybe they understand what's going on because you use the language that you talk to them in a normal life. So that's up to the strategic design. So I think that's the most important part. And in Eric Evans' book, it's kind of split around the ubiquitous language is at the start of the book, and context, bounded context and context map is later in the book. So Greg Young mentioned many times that you should start with chapter 11, then go back to chapter 2 and stuff like that. I don't know. I mean, when I was writing my book, I got to the same dilemma. You kind of try to move people forward and you kind of operate within a single context. Therefore, bringing the concept of the bounded context is kind of premature. But again, I'm thinking maybe if I ever do second edition, I would reconsider and bring it up and make more strategic, at least some pinpoints in order to prepare people for stepping into the strategic design territory and understand the importance of it. So in strategic design, we also separate, kind of categorize domain depending on their importance and often complexity. So the most important one that you can imagine that sits on the top is a core domain, and then we have something that needs to support this core domain. So there's all things around it, and there are generic subdomains, and I will talk about them one by one. So the core domain is where you do your best. I will spend a little bit more time talking about core domain in details, but now it's just that is the essence of why your business is the leader of that particular niche or industry or whatever, or you're trying to be the leader, or you're trying to make a difference, you're trying to find a differentiator between all other competitors, and that's where your core domain is. It doesn't necessarily fit with or match with your business line or line of business. It might be different. It's kind of a subset of things that you really can do better than any other. we talk about supportive subdomains, it's something that you can still not live without. I've seen a few articles explaining what supportive subdomain is. People say that's something that your business can survive without for some time. Actually not. It's not always like this. So think about the Transport for London. So let's say their core domain is, I don't know what their core domain is. The obvious answer would be the core domain is to move people around the city. And the most effective way, and sort of the price is okay and stuff like that. But so already a lot of concerns. So where is their core domain? I don't really know. But we get back to this later. But let's say there's they have supportive subdomain of kind of air conditioning stations. Could you really? You might live without it for some time, but the some time might be 20 minutes, half an hour. So escalators, could you live without them? On some stations, yes, but on others, it's really a mess. And you can't really ignore this, or you cannot live without it. It's just that it's not your differentiator. Everyone who is in the same business do it the same way. So there is a best practice, a good practice, well-known solution. So it's kind of thing you have to do. And maybe you can find your creative way of doing that, different from others, so you become more efficient, but essentially it's the same thing. So generic subdomain is very similar, and I feel people very much mix them together. But I believe that generic subdomain is something that is really, it's like, I mentioned the best practice before, and this in generic subdomain, it's not even the best practice, it's a solved problem. So, like you need a blog, where do you go? There is not much novelty going on in there. Before you were considering WordPress, and I know that some people use it, I do, for some other things, but for my blog I use static website generator. So like you have a variety of choice, you can go grab them, they're open source, free, and then you can start doing your thing. So, I mean, it is something, if it's not your business, per se, if you're not going to build a blog engine for a living and earn money on that, you would probably not consider building it yourself. You can buy it off the shelf. There are a bunch of examples, and one of the popular examples is payment processing. Like, it's a solved problem nowadays. Before it was like, if you remember this, e-commerce became a big thing, or started to become a big thing. People were wondering how we collect payments from our customers. In less advanced countries where credit cards were in the thing, like the Netherlands, I'm sorry to say this, it was virtually impossible until they come up with the interbanking system ideal, which allows you to pay with the bank transfers immediately. So with credit cards it was much easier, and then companies like Gorgona started to commoditize it, but you still needed a merchant account, which is a pain to get. And then Stripe came along and destroyed them, like almost all of them, smaller players, because it's just so easy to start. You don't need merchant account, they will handle it for you. And then Klarna comes, apparently from Scandinavia. I don't remember where their home is. They're very popular in Sweden and Norway. But I see them everywhere now. They give you the customer loan, actually consumer loans, to pay for your purchase, and they take care about the checkout, keeping the invoice in place, informing you about shipments and stuff like that, and do the credit checks if you ask for the loan. So quite a lot of interesting things that Stripe never managed to do, and they kind of gaining traction. So these things are commoditized. But imagine, or remember I mentioned a couple of names here. Keep these names in mind, and I will get back to them again. So let's talk about core domain for a while. So I repeat that the core domain is not a business goal, not your line of business. It's not a mission, a value. A lot of companies have a mission statement, set of values, and their goal. It's rarely you find yourself in a situation where your business has a unique business proposition or sells something that nobody else can sell or nobody else can do. You find yourself in the real life, in the real world, where you have a lot of competition, and every business tries to find something that would differentiate themselves from all other companies that are in the same business. And this differentiator is what the core domain is. It's what makes you stand out. How your business is different, what your business proposition is different, how you do things better compared with others in the same line of business. It's also the place where innovation happens. It's not necessarily happens by kind of you find out, let's choose this subdomain, a core, and innovate there. It doesn't happen like this. So usually it happens by chance. You would not be able to predict how your core domain would kind of shift. So because core domain is not something static. I've seen many people saying like, our business is e-commerce and our core domain is sales because that's where we earn money. I mean, everyone in e-commerce earn money on sales, but it's not the sales itself that make you different from others, except that you have something exceptional in sales on your e-commerce website that pushes people through the sales process so easily they kind of cannot resist the urge to buy. They almost buy like robots. Then you have a competitive advantage in sales. But all other companies, they have different ways of picking the thing. Like, I have the best stock, like I have everything you're ever gonna need in that particular space. Like, there is a company I buy my power tools from, Toolstop in Scotland, which says like, we have it in stock or not, and if you have it in stock, you can buy it. If you don't have it in stock, we just don't sell it. There is another company in Norway where I buy my power tools from, and they have like everything. They have very big, not stock, but product catalog, and you can kind of find almost everything you need. At the same time, I was ordering staples, and a particular staple size, I'm waiting for it since, I think, it's now November, and I'm waiting, I think, since June. In Toolstop, however, I wasn't even able to find those staples, so that's the difference. And every company chooses their way to differentiate, and the focus can change. So one day you think you do some novelty innovation in this place, and that can bring you competitive advantage, but it's not static. So you shift your focus and try to do something else. I give you an example about payment processing. Remember, we were talking about Stripe and Gona, that I don't know if this still exists in Klarna nowadays. We consider payment processing as a commodity. That's why I mentioned it in the first place. So we use ready-made off-the-shelf software or software as a service to handle these cases in our own software because we don't want to build it again. Make no mistake, for those companies, for Stripe, payment processing, the core domain, it's their kind of business, and their core domain is basically the ease of onboarding new customers and extensive, maybe their API is the core domain, I don't know, but it's one of the best APIs out there. So apparently it's not the dashboard. I was working with a service from, I don't want to mention the name, but it was ugly. I mean, it's just insanely bad. And when I switched to Stripe, I was really happy. And now you can even go to GitHub sponsors and create a sponsorship account, and they connect you to Stripe. That's how you charge, or your sponsors can pay you. And that's very interesting because they basically expand their business. That for us it's a commodity, but for theirs it's their core, and they make a living of it. So don't think it's like some domains are which it's generic subdomain. There is some novelty happening in there, but it's other people who do it for you. Now that's an interesting example on this picture. So payment processing again. So is the payment processing core domain of Transport for London? You would never say yes, because it's like they need to move people around. But apparently paper tickets and one-time use tickets, they were at first expensive on scale, and second of all, they were really a step forward from tokens and coins. But then they decided to move forward. So they want, this throughput actually depends on how much time you spend buying your ticket and standing in front of the cashier or the machine. So they come up with the idea of smart cards with NFC chip, but embedded envelope that they can kind of top up and put money on, and then use this money to move around. And that's where Oystercard was born. It's tremendous technical challenge because it works almost real time. And I still managed to do it. So, I mean, I imagine the investment was huge. And apparently, at some point, this became their core domain, and one of many core domains. They're so big company, enterprise, I would say, that they might have several core domains. But this created a significant impact. I think everyone who ever traveled in the UK in past 15 years definitely value this proposition and these movements to move away from paper tickets to Oyster cards. And then they didn't stop there. So they moved along and they started to charge you through wireless bank cards. And the latest development is using the mobile phone, Apple Pay, Google Pay, whatever. So there's quite a lot of innovation happened. I don't know who came up with this idea. I think after them, a lot of transportation systems in different countries started to adopt wireless payments. But I remember that I was actually very, very impressed by Oyster when I first saw it. So apparently, you might not even guess where the business and your ideation brings you to, and this is one of the examples. And generic for one is core for another, and that's what I talked about. Very kind of spent quite a lot of time talking about Stripe, and now Klarna is doing something else, apparently taking part of this market by bringing more innovation to it. Because to be honest, Klarna was not a good couple of years ago, but now apparently they found something, they started to do it, and they do it really well, and they expand it nationally now. So what's generic for one is core for another. And of course, all this off-the-shelf software is built by someone else for whom that's actually the core domain. So, and if you look at Oyster and you look at different examples, and I mentioned that the focus can change, and it's not always intentional that you can decide what your core domain is. Very often you find the new core domain, a new interesting idea, the chance to innovate, not in your roadmap, right? Because roadmaps usually formed by customer feedback, your own ideas, which you probably have a limited capacity to generate because you kind of know your business very well, but it doesn't really give you many ideas how to improve it, because for you it's kind of works, it's okay, it's great, and everyone is happy. But when going to the path of serendipity, looking around and maybe doing one thing and then at the end find the use for it for something else, that's very often what leads you to innovation, where you find a new core domain for your business. And I have one example for you. So remember this logo. Earth's biggest bookstore. I mean, it started not as big as not as big as it was even by the time this logo was a real thing. It actually was an online bookstore, and apparently they found out when they started to grow, they found something interesting, that they got tired of paying for their two different data centers and internet providers, and something that they were using like off-the-shelf ready-made solutions. They were not satisfied with that. So to say that's all crap, it doesn't work, it's unreliable, it doesn't fit our needs, it doesn't scale as we want. And we're paying probably too much for it. So they decided to build their own. And that's how Amazon Web Services was born. And the idea appeared, I mean, they built it already in the beginning of the 2000s. And the idea of creating a service available to the public based on that comes back from 2003, and around 2004, 2005, the early versions of Amazon Web Services start to appear. They actually were doing web services, that's why it's called AWS. And of course it grew beyond that, and this was born the moment when the public cloud was born. So out of serendipity, they built the system to support their business, and they decided to make a public business. They create a new business line, and now AWS generates 12-13% of the total revenue of Amazon, which is tremendous because the company is so big. And remember, at that time, it's end of 1990s and begin 2000s, there were software giants like Oracle, Microsoft, IBM, and many others that don't even exist anymore. None of them came up with the idea of public cloud. It was just a bloody bookshop that figured out that they actually can make something better than all the software giants all together, and created a public space with elastic computing resources and changed the world of distributed computing, the computing in general, and commoditized resources tremendously. I mean, the impact of public cloud created by AWS is hard to underestimate. And it comes from the bookstore. How good is that? So that's where serendipity and your internal innovation come together, and with innovative leaders and salespeople and the leadership of the company, you can come up with some brilliant ideas that were never actually, you never thought about making this your core domain. And apparently, if you have done it, maybe you would be next Amazon. So let's just start to wrap up. So how this process of finding models, finding new ideas, creating context or discovering bounded context and developing the language there, how it all happens. It happens through the process of collaborative design. And I think during this workshop there would be there were already talks, and there would be more talks about different styles of collaborative design, where the group of people come together. The most important thing is that I remember that when I first met Alberto Brandolini the inventor of event storming, he said the important thing is that you need to bring people with questions and people with answers to the same room and let them talk. It doesn't need to be as fancy as storming or something, throwing stickers around and stuff like that. It could be just one programmer talking to the one person in the business who actually doing things. It might be not very collaborative. It might be, you might start with just observing what they do. And when you observe them doing certain stuff, then you realize that this part can be easily automated. They never thought about it. So I'm a bit skeptical concerning things like we build our roadmap based on customer feedback. Well, customer feedback is great, but it's usually to improve things. But to create real novelty, the customer feedback is often not enough. I mean, I guess the customer feedback and your roadmap and your position in business, all of that creates this idea of that you're doing great sometimes, and especially if your revenue is good. But then you become complacent, and that's in the Canadian framework. If you ever stumbled upon this, there was a shortcut between the simple domain to chaotic domain that's created by complacency, where you actually think you're good. And in the most known example of complacent company is Nokia, who ran out of business within 5 years, from being the biggest manufacturer of mobile phones in the world to almost no one, because they probably weren't improving their phones based on customer feedback. They're creating fancy things, different styles of phones, stuff like that, where Apple was producing a single model, it's called iPhone, and destroyed the whole company. And then Google came along with Android, and a lot of things happened in the industry. That's where you don't want to be. And the collaborative design, it's basically pay more attention not only what business tells you, but come up with new ideas. And so I have a bit different kind of proposition what traditional people mean with collaborative design, like talk to business experts and understand what they mean and try to implement it in the solution space. This not always works. So try to be a little bit more innovative. You can provoke them and say, why are you spending 10 minutes to run this report? I mean, you don't even need a report. You probably need an email to know what something happens. Compared with you checking 2 reports from yesterday and today and find a difference. Or they might say, I never thought about it. It's really possible. That might be very complex. And say, well, notification based on reactive events is like 100 times simpler and 1,000 times faster than generating this report that our database cannot cope with anymore. Stuff like that needs to happen all the time. So don't really believe what the customers are saying, but listen what language they use and try to discover concepts. That's important. So business language still is very important. And try to isolate the context. So collaborative design is going back and forth and discussing things and going through ideation and proof of concepts and stuff like that, together with your domain expert together with your customers. As soon as the loop is broken, so you can't talk to people using your software anymore, you not always can go along and say, I'm doing a great job, because the feedback is not there. You don't really see the face of the person you build the software for. So now let's admit it, all models are wrong, but some are useful. So why I'm saying this? Because remember I mentioned the London Underground map at the start. At this current version, and it's not, it's wrong in terms of like it doesn't fit for other contexts, but it's not ideal. I mean, as I said, the transfer time between different lines is not mentioned there, and it's very interesting to know because it severely impacts the overall journey time. And it just doesn't fit. So until they find a better model, they probably have an app already. This is a very useful model, and it's been used for many years, so it's proved its usefulness and not uselessness, usefulness. It has proved its usefulness, and therefore, until something really innovative happens, we will still use it. It applies to many other models, so don't try to go with a perfect model. You will never be able to find it because you apparently will be lacking some insights, some knowledge about the domain, especially when you're just starting doing that. So don't be afraid of creating a model that you find kind of okayish, but you feel some itch to refine it even more because you still need to produce production code. That's what you paid for. You're not paid to create an ideal model. You're paid for to deliver software, right, that works, that brings revenue. However, you could innovate there too, or let's say iterate, it would be a more correct word, if you decide, for example, that you split team in two and then ask both sides to come up with a model for that particular domain and then compare the results. Interesting things happen. Apparently, some of them miss certain details that the other part of the team catch, and then combining together you might find a very useful model. You might also iterate on the model in terms of like, let's try to, what people say, throw away the model, right? Throw it away and then create a new model. You might find out that most of the time you're getting back to the original model because you usually, well, not usually, often you kind of know more or less what you're doing, and you already kind of thought about this model for a little while, or maybe for a long while, because you never got a chance to model it properly. But then at least you have some what is the alternative? The alternative is this and this and this, and that's the best one. And try to avoid being biased towards your own model. Maybe just look openly to what other people propose, and maybe you find their model more useful than yours. So this is how it actually happens, the collaborative modeling iteration around the whole thing. So you have the model, you maybe have nothing, and you have a bunch of scenarios. What you can do is try to execute the scenarios through your model. And then you need to kind of come up with the improvements in the model because not all the scenarios you were even considering before. So now you need to try to fit new scenarios in by remodeling. And then you create scenarios like events and states. This workshop is all about events, so you probably would know more about it by the end of the day. And you will make mistakes, and then you get back and try to refine a model several times. You collect rough scenarios, you list them down, and then you kind of start to distill. And then you need also to continue to probe it with code. Try to code it and see how it feels. Is it really going well, or you feel some awkwardness? Maybe you need to write too much code to handle certain scenarios. You need to get back and write a new prototype. And this all can happen in isolation, so you don't need to interfere with a lot of people in the whole organization. If you have a big organization, you can, even dealing with legacy, you can kind of build it on the side and try to iterate. But then the most important thing is not drown in this whirlpool. So you can't go there forever and sort of whirling and whirling and whirling and eventually drown. You need to kind of float up and saying, okay, enough is enough. So this code probe I made and this model that I come up with, they kind of match together to solve all the scenarios I need in a reasonably good fashion. Then stop there, deliver, and then challenge model with new scenario. and find if it fits. And maybe you need to complete a new model afterwards. Maybe you are operating in a different context. But again, start with something that has a decent amount of scenarios handled, so the business actually can start using the software and bring new scenarios in and iterate on the model and try to build some code and bring it to production. But always try to bring it to production when you stopped iterating on the model, and don't spend too much time on iterations anyway. So that's all for me today. I hope you find this talk useful, and now it's a question time. Thank you very much.